Hello again, Algebra 2 students. We're back into our absolute value function syllabus. We are now on lesson 3b. We're now dealing with horizontal absolute value transformations. So let's check off our booklet and scroll down. We arrive at the horizontal absolute value transformation. And here we can say that horizontal transformations move the function left and right on the x-axis, and we can see that by plotting this function, the absolute value of x plus 4. So let's come down to our table here. And again, we're just putting in inputs and getting out outputs, and f of x is again just a fancy word for y, or fancy notation for y. So when we plug in -4 in for x, we get -4 plus 4, which is 0, and the absolute value of 0 is 0. The next one, if we input -3 in for x, we get -3 plus 4, which is 1, and the absolute value of 1 is 1. And then if we plug in -2 for x, we get -2 plus 4, which gives us 2, which the absolute value of 2 is just 2. And then if we plug in -1 for x, we get -1 plus 4, which is 3, and the absolute value of 3 is just 3. And if we plug in 0 for x, we get 0 plus 4, which is 4, and the absolute value of 4 is just 4. Before we start inputting our values from this function here, I want to start by plotting our parent function that we learned earlier, which is at 0, 0 vertex, 1, 1, 2, 2, -1, 1, and -2, 2. That way we can look at it and compare it to our other graph. If we plot these points, I might have picked good points, I might not have. Sometimes you'll pick good points and sometimes you won't. Start at -4, 0. So I go back 4, 0. And then I go -3 and I get 1. And I go -2 and I get 2. And then I go -1 and I get 3. Doesn't seem like I'm getting the V shape like we want, so maybe let's pick some more points. The first point I think I'm going to pick is -5. So if I input -5, I get -5 plus 4, which is -1. The absolute value of -1 is 1. So I get 5, 1 as a coordinate point. And then I want to also put in -6. And if I put in -6, I get, for x, I get -6 plus 4. -6 plus 4 is -2. The absolute value of -2 is +2. So let's plot these points and see how that works out for us. I got -5, 1. So there's -5, 1. -6, 2. There we go. Now I have found my shape for absolute value. And what we can notice about this shape is, again, it's in the V, just like the parent function. To describe this, what I would say is that it still remains on the x-axis. However, it's shifted from the origin to the left 4 units. And if you look inside the absolute value, we have a +4. So what this tells us is that when we're dealing with horizontal transformations, we're dealing with the inside part. So what's inside the absolute value bars. And we move opposite of the operation sign. We're going to describe that it moved left 4. And then now we're going to use the information that we just gathered from this table and graphing situation to come down here and take a look and plot this absolute value function without a table. So we know that when we had a +4, it moved to the left 4 units when it was inside the absolute value expression. So now when I come down to this function, that's going to tell me that it's going to move to the right 2 units. So the way I would graph this is I would come over here and I would take my parent function. We'll do the parent function in blue. And I know I'm at 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. There's my parent function. If I'm going to move to the right 2 units off of my parent function, Another way to do this is to move every point 2 units. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And when I draw my new graph, I can see that I shifted 2 units to the right when the inside of my absolute value expression had a -2. So you go opposite of the sign horizontally. Describe the transformation, I would say right 2 units.